Good morning, everyone. Welcome to our session on CST Studio Suite 2022 Technical Enhancement Updates. Thank you for taking time out of your busy schedule and joining us today. I am Mehul, a marketing manager for Vias3D. Before we start the session, I would like to inform that to keep this session an interactive one, we will be having 2 to 3 poll questions, which will be launching in between the session on your screens. So we request you to respond with the appropriate answers when the poll is on your screen so that we can get to know you a little bit better about how you are using these things. And in addition to this, we will take all the questions towards the end of the session. So in case you have any questions, you can type them in the questions box and send them to us, and then we'll take them towards the end. So without taking much time, I would like to introduce our speaker for today and then hand it over to him to start the session. So our speaker today is Pankaj Jha. Pankaj is an RF and microwave engineer with more than 10 years of academic and industrial experience in modeling and simulation, different type of electronic problems. He has worked in antenna array, filter design, microwave, bioelectromagnetics, EMI, EMC, and low frequency electromagnetic problem fields. He leads the electromagnetic application at Vias3D. He worked with Dassault Systems as a solution consultant and was responsible for various industries like aerospace and defense and high-tech industries to manage the technical portfolios for the CST Studio Suite. He is a graduate of IIT Delhi, where he studied radio frequency design and technology. So with this, I would like to invite Pankaj to start today's session. So Pankaj, over to you.
Yeah, thank you, Mehul, for the introduction. And I'd like to welcome all the attendees for our technical enhancement webinar for CST Studio Suite 2022. So let us begin this. And So first, the agenda of the webinar will start with introduction and overview. Then we'll discuss about all our portfolio with EMAG solutions and 3D experience offer for CST Studio Suite in 2022 version. Then we'll discuss different industry processes, and within those processes, we'll discuss about different enhancement which has been done for different market. So the first will be antenna engineering and certification for 5G network design. The second one will be more on semiconductor and electronic design analysis, EDA segment. Then second will be more on aerospace and defense section, where it will be aerospace communication and detection system performance. And the final one will be more on vehicle and electronic system performance management. So let's begin with introduction and overview. So the first is the SIMULIA Electromagnetics Portfolio. This is one of the most comprehensive suite for high frequency and low frequency EM simulation. Our flagship product is CST Studio Suite. And from 2021 and 2022 version, it can also license of Opera FEA for low frequency application as well. So one single license of CST Studio Suite can give you the option to simulate a problem in low frequency Opera FEA as well. And it is available as a desktop option, but CST Studio Suite a standalone package can be both desktop and cloud computing. But there are a lot of roles which has come for CST Studio Suite on 3D experience platform, and the 3D experience platform give you both on-premise and on-cloud option, where you can run your CST simulation on native 3ds cloud. And there are different other roles like electromagnetic engineer, antenna placement electromagnetic engineer roles. And CST Studio Suite shares the tokens and credit licenses with all SIMULIA products. like Evacus or PowerFlow. If you have tokens and credits for 3D Experience Cloud, you can either run CST or PowerFlow or Evacus uh, as per the need of your industry. So in a company, if you have engineers of electromagnetic domain, Evacus domain, FEA or a structural domain with same token and credit, they both can run either CST or Evacus together. So those are the flexibility which has been bought into the licensing scheme, and it is available through 3D Experience platform. Those roles like all physicist analyst role, electromagnetic engineer role, and antenna placements, and electromagnetic engineers. So it is upon reflecting what the pandemic would have been like, have we not had such advanced digitalization and communication as we already have, that we start appreciating the benefits of this technology. It has, however, also highlighted the shortcomings of current technology and the need for sustainable innovation in communication, both between humans but also between a smart network of all sorts. This presentation will introduce you to SIMULIA Electromagnetics Portfolio, showing CST Studio Suite major enhancement in version 2022. The technology enhancement will be presented in the context of major industry processes we serve, implying that CST Studio Suite can be applied across multiple industry like antenna engineering, as I said earlier, EDA, aerospace and defense, and the transportation and mobility, where vehicle and electronic system performance management. So and going on directly to electromagnetics on 3D experience, what are the update in 2022? Uh, just a few words more on that. We introduced cloud compute already a few years ago, and continue to expand the solvers available through this technology, which is based on a token or credit system. And you can see, like, on a cloud compute, you can use like 4 GPU 24 cores or 8 GPU 40 cores 48 cores machines, and you will have a CST on cloud, or you can have a CST front end or S2K on premise, and you can set the simulation directly on cloud from there. So new in 3D Experience 2022, another thing is like ability to store the PCB layout data. So 2021 version was not supporting ECAD tools, or like a data from a ECAD tools like Juken, LTM, Mentor Graphics on cloud. Standalone CST license, as users are aware, it has been supporting from very long time, but on cloud, like PCB layer data is supported now from 2022 version. And we continue to expand the visualization capabilities on 3D Experience platform for our simulation results. In 2021 version, 3D and 2D field result visualization was not possible on a cloud, but on 3D Experience now, in 2022 version, it is possible, 2D and 3D field visualization. So towards the end of 2021, many news agency reported that airline carriers in the US are facing pressure from the government, that airlines and aviation unions should delay the deployment of 5G on these carriers. There are concerns about potential electromagnetic interference of 5G with sensitive aircraft electronics like altimeters that could prevent engine and braking systems from transitioning to landing mode. Uh, so, uh, uh, so there has been a flag by government not to make an early deployment of 5G because of it can affect electromagnetic interference, can affect the altimeter directly, and could prevent the engine and braking systems while landing. So 5G or the fifth generation mobile network is promising and to a large extent also offering connectivity to just about everything at a much greater speed, at much better reliability, and at a lower latency than any other cellular technology released thus so far. So the benefits are obvious, but the challenges are numerous. This is where electromagnetic simulation software has found its place. These devices cannot be designed without sophisticated software, and ensuring that 5G networks are not susceptible or responsible for electromagnetic interference is best done by engineers in conjunction with simulation software like CST Studio Suite. So now on to the modeling side. Since the 5G network environment may be large, like we have to analyze 5G scenario on airport, city ports, and or factory, we introduce the possibility to import 3D XML graphics from 3D experience as surface mesh into CST Studio Suite with great improvement in performance. These models will be very, very large, mammoth type of mammal models, which required huge amount of mesh. So right now we support 3D XML graphics import, and we continue to improve the access to 3D CAD data. And as usual, we update the 3D CAD import from main mechanical design tools like CATIA or SolidWorks. The picture on the slide represents a battery factory imported as a mesh. This year we introduced further user benefits by restructuring the navigation tree and adding this navigation tree and adding the single sets into folders in a hierarchical manner. So let me take, sorry, let me take the pointer. Yeah. So the next one is on the antenna arrays, and multiple excitation list has been introduced in antenna array task. And with those excitation list, what benefit we can get in order to ensure the greater bandwidth, higher download speed, and the connectivity requirements, arrays of antennas are usually required. Simulation of full 3D antenna arrays can be quite time consuming, which is why we have spent a lot of effort on improving certain parts of the array design workflow, and I would like to present some of these enhancements which are specific to antenna array design. Let us start with the array task, which is a part of 3D and schematic in CST Studio Suite. The first main feature is that you are now able to import n number of excitation lists based on your TSV format. They are then indexed and selected in simulation project via a parameter in the list. Those parameter list will be formed, and you can even use those parameter list for parameter sweep and can be quickly executed either in post processing or for a T-solver run. And then for all the different excitation list, you can see how the beam sweep is happening for different scan angle. So the next one is uh, more on the far field post processing array factor enhancement. And in this, with regards to far field post processing and in particular array factor multiplication, it is now possible to fully parameterize this setup and even include VBA commands. So inside this, if you see, like there was an array factor block over here, like this array factor block now can take parametric input like center frequencies, all those parametric inputs, and even in amplitude and phase, those parametrics can be implemented, or directly a VBA command can also be written over here. We also added automation of unit cell projects created by this array task. This way the setup even supports the new feature for multiple excitation list. So it is really easy to take either an isolated or active element pattern and quickly estimate the finite array performance. So the next one is with frequency domain solver, and this is the implementation of domain decomposition with frequency domain solver. And inside this domain decomposition, if we see, as I said, the same thing, solver and mesh adaptation, robust automatic detection and repeated domains, like having a unit, say having a domains of a big array, having like uh, area of 5-6 domains where we'll first see the far field and then later it will combine together, and we can give even a frequency domain solver that much speed up and the memory reduction, so that you get the simulation result faster. If you see the far field realized gain over here, one is with general purpose solver and one is with domain decomposition frequency domain solver. So general purpose solver will take little more time, but domain decomposition solver, if you see, the result is almost same, but it will take the speed up of simulation will happen by 5.8 factor, and the memory reduction will be like 77%. So now the next one is more on the 5G workflows. And inside this, we are continue to expand the 5G post-processing offering, and some of the major news in terms of version 2022 improvement in 5G post-processing are: we have streamlined and simplified the 5G workflows, such as removing the requirement for a separate iSolver object. These simplifications lead to a significant reduction in RAM and disk space, as well as much fast processing. So we can see over here between version 21 and 22, for the same problem by TLM solver, and the TLM solver compared to transient solver, the finite integration technique, it uses a cell lumping technology and it reduces the mesh cells from 150 million to 5 million. So what we can see with this TLM solver, from version 21, it was taking 8 GB of RAM, 8 GB of disk space, RAM of 16.3, and total processing time was 62. So now it has reduced to 23 minutes, 3 times faster, 7 times less RAM, and 8 times less disk space. So the workflow for 5G has been automated, and we are significantly improving and streamlining this workflow in past years, and now this has evolved for CST Studio Suite 2022. And we have included an enhanced smartphone demonstrator model is available in CST Studio Suite 2022 component library. Please have a look at these arrays and codebook examples. So there are codebook examples and arrays available. So, the 5G wizard has a new feature whereby the phase between different beam. So if we see the phase between different beam, polarization can be swept. This can be swept in order to maximize this power spectral density, especially varying power spectral density. If we sweep this uh, vertical and horizontal polarization for different code book phases, then we can get those values over here. So the next one on the 5G workflows is channel impulse response, and dedicated, these are dedicated to 5G application, more dedicated on indoor and outdoor propagation application. and which is an extremely fast solver for antenna placement, and this has been done with asymptotic solver, and this solver is extremely fast for antenna placement, radar cross section analysis, and also for propagation analysis in large environment like buildings or even outside. First big new feature over here, as I said, it is a channel impulse response. This is particularly important for 5G communication propagation analysis. As you can imagine, for such high speed application, there are several different channel parameters that can be computed. And I don't wanted to go too much details regarding these, as they are also a bit of a specialist topic. But if you are dealing with such channel impulse response analysis, I'm sure that this new feature is very welcome, and you can get in touch with any of our engineers to discuss more how these analysis can be executed. So more on 5G and safety. Ensuring human safety remains one of the most critical parts of antenna design, but especially so for 5G design. This year we have unified the voxel data import GUI, and we continue to increase the variety of available human bodies to be used in full simulation. This is on in the next slide, but if you can see over here, it is now a part of this macro that all the models are there, and this comes under a standard S2K CST Studio Suite package. Like human body import is completely free now to our user from 2021 itself. Now, in collaboration with German Cancer Research Center, uh, in the human model creation project, very detailed models from MRI scans are generated and now being available in bioextension files. So bioextension library user can download from our Simulia website or Dassault website, and they can get all those dynamic model with very detailed model for everything like Gustav, Laura, Mildred, and Fred. And this has been in done association with German Cancer Research Center. So when it comes to 5G, then post-processing is one of the factor that we have to consider, such as the calculation of SAR can be quite time consuming on large heterogeneous lossy models like human body with a smartphone and hand coming into the picture, and we have to do the SAR analysis. The mesh generated in this case is 50 million mesh cells. We have 27 3D field monitors, and we can see the comparison with respect to 2021 and 2022. We have tremendous improvement in time taken to complete the simulation and analyzing all the 3D monitors of SAR you want. So the solver loop time, which was like 509 seconds, has reduced to almost nearly half to 333 seconds, and the post processing of all the far field result has reduced very significantly, and it is right now with 27 3D film monitors, we can only see 9 seconds compared to 180 seconds before. So for these applications. Now, this is the summary of first part, antenna engineering and certification for 5G network design, what we did. So several improvement for array design, extended 5G specific post-processing, enhanced human model library, GPU performance improvement for far field monitors such as SAR, and I believe this is the time for our first poll questions.
To answer the poll which you see on your screen, the question is, are you using CST Studio Suite in your product development process? If you are, then you can just select the option yes, and if you don't, you can just select the option no, and we'll just keep this poll open for a few more seconds, after which Pankaj can continue with the presentation. So you just have to click either on the yes or no option if you are using the CST Studio Suite in your product development process. So we will close the poll in 10 seconds. So I see most of you have voted. So thank you for your response. Pankaj, request you to continue.
Yeah, so the next section come on electronic design analysis. In the previous section, we discussed about 5G. We focused on antenna design aspects, but closely connected to antenna design is, of course, the electronics. Let us look at some enhanced functionality for these technologies. So with CST 2022, we have added the possibility to store PCB layout data on 3D experience, which I mentioned before. Not only is the data from CST Studio Suite stored on the platform, but most of the common ECAD tools are supported. So the next is on the modeling side. CST Modeler offers since many years the possibility to band solid around other solid. The cylindrical banding doesn't require any extra solid, and it is very robust. Now you can see there are multi-layer PCB, and you can bend as a layer stack up in whatever shape you want of bending of your PCB. It takes just 5 seconds, 40 seconds. So which was previously it might be taking long time, but this has been reduced, and this operation has been very smooth for 2022. Now, if we see in the next slide, pre-2022, the drill shape for the via, it was coming as a circular. Now it can take any rectangular shape for vias over here. You can edit and modify these drill shapes and in 2022 version. This is more on the PCB Studio side. So more on DDR4 analysis, the workflows, there are several improvements in 2022. Two of them are shown in the slide. We can now indicate whether a task failed or passed over here. And this is properly summarized in a table of timing result with predefined limits. What are the limits? And also, if you see in the eye diagram, now we can keep these measured lines. So over the lines can be kept, and that can be used to measure the group spread and the reference distance, which was not possible in 2021, but it is now part of 2022. So in the EDA workflows, a lot of us do IR drop analysis for SIG power integrity at DC. So here nonlinear SPICE models is supported now, and it is supported in two ways, either by voltage VRM, what we called switch mode VRM without linearization, or you can import a nonlinear SPICE model. So either through a switch mode voltage regulator model, or which is non-linearized, or you can import the SPICE circuit directly for IR drop analysis with nonlinear elements. More on the circuit level side, like circuit level simulation is critical for electronics, and we therefore continue to enhance also our schematic capabilities. For instance, we are now distinguishing between conventional IBIS buffer model with IBIS AMI buffer model. If we see, it has like AMI marked on this thing. So where those are needed, so conventional are more for a statistical workflow, but when it comes to transient simulation, then IBIS AMI buffer model will be used. So the another enhancement is on the EDM tool. As we know that EDM is very popular in electronics industry uh, for better resonant behavior in simulation by enhancing the fitting of the data for getting the S parameter of a SPICE circuit. For the version 2022, pole placement has been enhanced, making the macro model for resonant system more accurate. If we see the increased accuracy and increased speed, and it reduces the computational resources. The second update is new adaptive sampling method dedicated to passivity enforcement. It replaces the previous method based that was on equidistant sampling. It allows a faster and more efficient passivity enforcement. And the last update of item 22 is the automatic reciprocity enforcement. This new functionality enables the automatic detection of reciprocal data set at importing stage. The reciprocity is enforced and only diagonal and upper triangular part of the transfer matrix are stored. So less computational resources, as I said, both from memory and time perspective. Now, in conclusion, for the item, fitting can be applied to S parameter block on the schematic as well. Here we can see how to enable it to ensure more accurate and smaller fitted models for highly resonant structure. This is for DC-DC converter, and for DC-DC converter, uh, item fitting can be applied with vector fitting can be applied through option in a schematic itself. Now, we have introduced a drift diffusion solver in our low frequency solver family, and this solver can be used to simulate uh, semiconductor devices like PN junction diode or NPN junction BJT, of which the conducting traces are in the micrometer range. The drift diffusion solver belongs to low frequency solver family. It is based first on electrostatic field calculation, and then it applies to a Gummel iteration scheme to compute the electron and hole density, which are needed KPI for this industry. The plot shown is a part of workflow for electro-optic modulator design. We have had this modulator workflow for a while, but it was not self-consistent and people had to enter the junction capacitance a priori. The new solver allows us to calculate that capacitance self-consistently. The results shown are the single-ended capacitance per micrometer as a function of bias voltage. This concludes the section on electronics, and we can see different enhancement for this year is like new functionality for semiconductor workflow, then domain decomposition and IR drop, new modeling capabilities together with 3D experience, 3 new blocks for use in a schematic. I believe next poll question over here, Mehul.
Thank you, Pankaj. So the next poll question we have is, do you think electromagnetic simulation can help you solve problems coming into your product development process? So once again, a simple choice of yes or no. So we request everyone to just click the right option. I'll just repeat the question. It is, do you think electromagnetic simulation can help you solve the problems coming into your product development process? So we'll just keep the poll open for a few more seconds, after which Pankaj can continue with his presentation. I request everyone to just select the right option.
Okay,
Okay,
so
so we'll close the poll. Yeah.
Yeah. So the next topic is aerospace communication and detection system performance. As I mentioned earlier, that electromagnetic safety for 5G network in and around aircraft and airport is a current concern. Over and above the uncertainty relating to 5G, the aerospace industry is growing, and there is a noticeable trend towards autonomous flights. With the proliferation of smaller aircraft like drones or air taxis, antenna placement and radar system performance are becoming even more critical. For these electromagnetic environments, which are often electrically large with frequency typically in the gigahertz range, and a special solver method and functionalities are applied to the simulation. So the electrical size of this type of problem go to 2000 lambda, 3000 lambda, and we need a special solver to solve this type of problem. Whether the electromagnetic environment is due to natural events such as lightning strike, or whether the EM environment is desired such as for communication purposes, or whether the electromagnetic environment is not desired such as radar or other defensive application, we have a solution for you. So the first thing over here, this was a long time wish of ours as well as of customer to have unit cell analysis in eigenmode solver. This is supported in frequency domain solver for long time ago, but now this has been introduced in eigenmode solver. This helps in many different application like radome design for radar systems, and design of frequency selective surfaces of that radome, and we need a smaller unit cells to do such type of advanced material analysis. So this is not only the application through where unit cell are desirable, also in the design of infinite arrays, this is very useful feature. So so if we see more into area of uh, electronic band gap structure or like photonics, so this unit cell boundary with this solver, that means with a slanted grid angles can be defined for the analysis of infinite arrays. Here is a typical hexagonal cell layout which uses a 60-degree grid angle. In addition, there is also a new project template for this particular case where the phase parameters are set up to sweep over the irreducible Brilliant zone. This can allow the construction of dispersion diagram containing the TE and TM modes. So this was a long wish feature to have in a frequency domain solver. So now with the phase sweep of the parameter, we can get the Brilliant zone and the electronic band gap of this. So for both for TE and TM mode, we can quickly generate the dispersion diagram. Now comes the antenna array. So when designing antenna, there is often a space limitation, like I have to put antenna on mobile phone, so a space limitation, or like I have to put antenna on aircraft. Also, there is a space limitation. We can't make an antenna certain height. Let's take our a SARC antenna is placed or wing-tailed antenna is placed. So we can't give about certain height because it will uh, mm, destroy the aerodynamics performance of an aircraft. So in antenna megas, you can give your spatial limitations. So we can give those limitations over here, and then it will tell us like in which direction those limitations are not met. It will give with red, and it will also give you one fitness factor, which is one of the best, like 1, 0.9, those fitness factor it will give. So these are 4 cases which are meeting the performance, but if you see these two, these are not meeting. It is telling like in Z direction, during your height direction, this antenna will not be useful for certain applications. So those type of things also we can do in antenna megas where you have a space constraint in your design. So now the next is like the reflect array. When So in the reflect array, if user have used the antenna megas, we are aware that shaped reflectors was always possible in antenna megas. But now a new class specifically for reflect array has been added. The first implementation is based on only rectangular patches, but we have a plan to have other unit elements in future, not only this one like hexagonal unit elements or like triangular unit elements. So those type of even will come for reflect arrays. The nice thing is that you can define many different objectives like gain, scan angle, number of elements, overall size, uh, and the substrate and all those things, and even your specification, what will be your feed beam width, substrate properties, feed position in this reflect array template in antenna megas. So some of the other important is field decomposition approach, which we call source coupling, and here the comes into play of hybridization of solver depending upon the electrical size. Like right now this 5G array antenna is placed on a post, and it is at certain slant angle, if we can see in this scenario. But most of the scenario there will be not on slant angle, it will be placed 90-degree, or it will be not off axis. But some cases there can be a slant angle, and in the slant angle when you store the near field, and when you take the near field of antenna and that you place in iSolver, when you do the platform analysis, sometimes more improvement was needed for that. So we have incorporated that simulation result have a more improvement in this scenario. So overall simulation performance using T-Solver and iSolver for slanted model has improved. Source simulation projects are smaller and axis aligned thanks to the rotated field source monitor. Now you can have a rotated field source monitor in your source simulation, which is a time domain, and then you can transfer that to integral equation solver where the platform analysis will be done. So next uh, is the whole hybrid simulation block. We know like in CST, you can bring the simulation project itself. You can refer to the simulation project itself. Simulation project reference block directly can come. What in 2022, what is the new addition is that even the hybrid simulation bidirectional task can be directly bought over here in schematic, and you can add other components over here, and you can perform all other circuit tasks like S parameter except the transient co-simulation. AC combined result for far field will be also added in service pack SP2 for this one. And these are the result driven after adding the hybrid simulation task with other circuit parameter. So the next other enhancement in this is interference task, if we can see over here. And with this interference task, what are the new things which has been introduced is one-to-one and end-to-one interference, which was already there, but whole the workflow and the performance improvement has been done. And if we see the comparison of this, so a lot of comparison is that there is a time improvement which have achieved, and all the GUI has been changed for this case. So this is one particular example related to that on the interference task, where we can see there are 10 different antennas on your aircraft, and you have one-to-one task and end-to-one task. And between 2021 now from starting from 2020 itself to 2021, you can see the improvement in time for simulating those problems. And this is fairly large problem with 832 transmission and around 1700 RX channel. Number of TX band is 9 and RX band is 15. So for that, we offer the interference task tool, which is our tool for analyzing RF system performance in complex environment with multiple radio systems. So the next is on the Spark 3D side. So radar system often contains waveguides, and not only the radar systems, like let us take a satellite communication which is happening at very high frequency, those contains a waveguide antenna or waveguide structure, and the RF breakdown power is becomes more critical in those type of application. We have therefore introduced a new task for calculation of such uh, RF breakdown, and this uses Spark 3D for calculation. So let's take you make some changes in the model, and you don't need to transfer the mesh from CST Studio to Spark 3D again and again. Now there is a link established, automation link established between the Spark 3D and CST. So when you update this task, then the Spark 3D GUI will open up, and you can change the power or any changes which has occurred in model that will be directly reflected in Spark 3D. So this environment is available in 2022. This is more on the automation of the workflow with CST Studio Suite and Spark 3D. So further, we can see in the solver improvement on the geometrical things. So in the geometrical side, for many years we have had a tuning slider in the circuit environment, but now finally we also have this for 3D models. When the sensitivity analysis is executed along with one of our high frequency solver, in post processing you are able to instantaneously use tune the S parameter option. Now simply right click on the S parameter folder in the tree and activate the sensitivity tuning. So so then to complement this, another long standing wish has been realized, and that is to have sensitivities calculated for any geometrical parameters. This means that you no longer need to go through tedious process of defining phase constraint now. In addition, if we now go and optimize using the trust TRF, this trust region framework algorithm, these sensitivity values are also directly exploited, and you can see that it converges much faster compared to the finite different approach which we were doing in 2021. Now the goal function has converged in 20 iteration. Earlier it was like 70 iteration, giving the same result. So geometrical parameter sensitivity has been done, and the sensitivity tuning has been implemented in 3D. It was available in circuit schematic, but now it is available in 3D for sensitivity analysis of any problem. So now comes high performance computing. It may be necessary to simulate full 3D model, and in that case MPI may be the best way to approach the simulation. Extremely large models are very often solved by using MPI computing, that is splitting the simulation into smaller domains and distributing the solution distributing the solving of these domains across multiple computers. That of course means that there is a lot of data to be transferred across the network, and matrix calculation part of the time. If you see what it is we are trying to say is that in 2021 and 2022, like when you have a big problem, then we try to approach through MPI computing, and the MPI computing breaks the problem in different chunks, and So there will be download time, then there will be merge time, there is a total time, then there will be a time domain solver which will be doing a lot of post processing. So all those things, the time reduction is too high. Earlier in 2021, like for a given problem, it was taking 33 minutes. Now it is taking 7.6 minutes. This was one of a problem from our customers, so we cannot show you what the problem was, but it was an extremely large problem for aerospace and defense application. So this comes to the summary of this area, and we can see that simplified certain steps in array design. Then there is interference task, workflow improvement, RF breakdown analysis enhancement, general MPI performance improvements. I think next poll question, Mehul.
Sure. Thank you, Pankaj. So the last poll question for this session, and the question is, do you want to know more from our technical team and explore how electromagnetic simulation can help you in your area of work? So if you feel you would like to know more about how the CST Studio Suite or the electromagnetic simulation can help you, please click on yes or no. So I request everyone to just select the right response, and we'll keep the poll open for a few seconds, after which we will continue with the presentation. So I see most of you have voted. We'll just wait for 10 seconds. The people who have not voted can just select the right option. Okay, so I think we can go ahead with the presentation now. Over to you, Pankaj. Thank you.
Sure, thanks. Okay, so the next part is vehicle and electronic system performance management, more on the TNM side. So the first improvement is on the CST 2020 version. We introduced support for thin panel materials using our frequency domain solver. It was already supported for TLM solver, like when we are doing all EMI, EMC analysis, thin panel materials comes into play. And it was with transient solver, asymptotic solver, even for other radar application. It was already supported, but now in 2022 it supports for frequency domain solver as well. So there are same materials that the time domain solver has been consuming for several years. The thin panel materials have been defined as seats. So if you see a normal material with 5 layer has a equivalent model of a thin panel now, which is supported in frequency domain solver as well. So earlier the problem was taking more time for messing and solving the problem. When it is a 5 layer for shielding effectiveness, there is a wire with a current, and we are trying to see if there is a shielding effectiveness, then how much signals pass through this shield, or how much it radiates out of the shield. So that we were trying to see. But what was happening, if we are using a frequency domain solver with normal material in without using a thin panel case for the same problem, then it would take more time to simulate the problem and more number of tetrahedrons. But now this has reduced to, let's take, if it was taking 1 minute for normal case, then now it is taking only 0.35 minutes, and the total simulation time also reduced to zero point 0.8 cases, like the 8% over here. So in this slide, we compare a small example over here of a wire in front of the shield. Now, the another workflow for this is for more on the cable studio side. If you see, due to the addition of thin panel for frequency domain solver, it becomes possible to simulate a structure with a shielded cables at low frequency within a reasonable time using a frequency domain solver and thin panels. This example shows the significant speed up which can be expected for radiated emission simulation at low frequency. The plots show the E field from shielded cables, and one is for TLM plus CS, TLM plus Cable Studio, and another is with frequency domain solver. Now you can see the significant improvement of having the thin panel in frequency domain solver. So the problem which were taking 42 hours has been reduced to 0.5 hours. So a significant improvement without compromising on the results. The results are almost nearly same for when we are looking at the peak levels. So this is improvement in this side. Mm, Advanced driver assistance system and autonomous vehicle have been a very hot topic in the recent years and continue to be for the in the future. As you can imagine, detection analysis is a major part of these systems, and I'm glad to say that we have tools available for the full chain of simulation, from individual radar sensor design up to virtual testing, and now also to virtual test drive simulation with AV simulation, which is a part of Dassault simulation and Dassault system portfolio. So now you can do a real-time virtual test drive with radar antenna or ADAS systems built on a road environment. This is a typical road environment, and on that we are trying to analyze it. So the next another workflow, more again for automotive environment. Here also it is implemented with asymptotic solver. Uh, and this new feature supports the virtual testing of this driving assistance system, range or Doppler map calculation. If you see, this is a bumper, and we have two things which is moving targets, two target scenario. So range and Doppler radar map is used to compare simulation scenarios to see the real radar sensor data. So this is an important feature for virtual testing of radar sensors or systems. Here you see a test scenario with two targets 2 meters away from the radar sensors, uh, moving in different directions. So the radar sensor one is moving in this direction, another is moving in this direction with different velocity. On the x-axis of the plot, you see the velocity of the object, and on the y-axis we see the distance or the range of the sensor. On the left we have the simulation with bumper in front of the sensor. This bumper is there in front of the sensor, and on the right the same simulation but the time without bumper. This is the same simulation without a bumper. So you can analyze the effect that different car body parts have on the radar, for example. So I mentioned earlier the new possibilities for simulation of cable hardness at low frequency using a app solver. However, whenever a complex cable cross section is required, and especially when the frequencies are higher, cable studio should be used, like this type of cable, complex cables with a lot of core elements, and then we should use, rather than designing directly into a 3D, we should use a cable studio at high frequency. So several improvements have been made to the cable solver. Two of the features are shown here. One is very thin screen and low frequency, and now we can see how the simulation time has reduced from 2021 to 2022. So furthermore, if we see, these are more on snapping or interactive circuit design. The schematic offers in 2022 release the possibility to snap components in and out of an existing circuit. You just to drag and drop the components or block on the nets you wanted to insert it, and it will be automatically snapped in or snapped out. So the next one, for experienced user, we enhance the connection editor. So after entering the editor mode, you'll be able to select electrical net from the list or interactively on the schematic. So this net list can be interactively used or snapped in the connection editor. You can right click and you can get a connection editor, and then you can select those netlist. So before to 2021, we were having only a rectangular windowing function for FFT transient task, but there are a lot of windowing function from the signal processing side. So all those windowing function has now been part of implementation, like Hamming, Kager, Bessel function, Kager and Bessel function. This is an example of input signal with Kager Bessel function and its comparison with a rectangular Bessel function. So the furthermore in this side is a schematic submodel block of hierarchical circuit setup. Uh, so we know like electronic simulation usually combines some sort of 3D simulation. So 3D simulation with a schematic, or like behavioral simulation with circuitry. Therefore, the schematic is very important in this workflow. Several important improvements or new features are introduced in version 2022. We have entirely reworked the design studio block, making it fully parametric, clonable, and most importantly, there are no limits to the hierarchy levels. This will make it possible to have a much simplified layout now in a schematic window. So MDIF data interchange format was already in CST Studio for exporting the data from CST to another software like AWR or ADS, but now we support CST to import the data from other software as well, or from the measurement, either from a software or measurement. Those MDF block can be connected to the rest of the circuit, and parameter sweep can be launched to analyze, for example, the S parameters over here. So uh, we know like multiple S parameter from the network analyzer or other simulation tool can be brought into MDIF, and we can connect those into different circuitry which would have been in the schematic, and then get a final S parameter as well. Here we have shown a simple example with connecting ports to that, which has come from the measurement to show you MDIF. But this has very vital role to play when you are wanted to keep like one portion, you only wanted to have the measured result, and other you wanted to simulate together with a measured result. So the summary for this section is like thin panel simulation for frequency domain solver, virtual testing support with asymptotic solver, solver specific improvement like performance of cable studio, and circuit level improvements. So with this, I would like to introduce like what we do and who we are. We have like a multi-industry experience from automotive, high-tech, medical devices, aerospace and defense, oil and gas, petrochemical and process. We have a global presence: USA, Canada, India, Mexico, and Turkey. And we are opening a lot of other segments in different countries like Italy. A global team of 170 professional engineers having 18 PhD and masters in different domains, from structural, electromagnetics, optimization, and reliability. We do both software sales and services. We have a dedicated team of 30 people who do services for our customers and consulting services for our customer. We are one of the top Dassault System Platinum partner, and we are a part of advisory group. So we are a one-stop solution for PLM implementation, training, software sales and support, automation, and machine learning based problems. So these are our contact information if you would like to reach to us or our sales representative or technical people for any support on CST Studio Suite or Opera or 3D Experience platform. With this, I would like to conclude this webinar, and I'll be open for questions.
Thank you, Pankaj, for this informative session. I am sure all of the audience members have got a lot of value from knowing what is new in the electromagnetic field in this year. So we are open to questions now. In case if you have any questions, you can type them in the questions box, and Pankaj can answer those for you. So feel free to type them in the chat box or the questions box in case if you have any questions. Okay, so we have our first question, Pankaj. It is, does 5G Wizard and Human Body Library are they part of the standard CST Studio Suite?
Yeah, a nice question. So those 5G wizard and has been implemented from couple of years now. So it is a part of a standard CST Studio Suite purchase, both human body, voxel body model, and the 5G wizard. So it will enhance your 5G workflows now, and no extra money to be paid for these things. So it is a part of CST Studio Suite standard package S2K.
Okay, thank you for the answer, Pankaj. We have our next question, which is, do you have dedicated workflow ready-made for array task and interference task to be provided to the customer?
Yeah, so we have because we feel like a lot of application are based on industry processes experience, and we believe on the workflow for different domains. And so the workflow for array task and the interference task is available, and we would tell like customer to get latch with one of our technical support specialists. They will help you with those type of workflows.
Okay, thank you for the answer, Pankaj. We have one more question, which is, what type of solver is used for antenna placement analysis on CAR or radar design of CAR, and how is hybridization of the solver performed?
Okay, so yeah, a good question. Like antenna placement analysis or like a radar design on automotive environment. Here, the electrical size used to be in a 500, 5,000 lambda, 2,000 lambda. So we have to do like a domain decomposition, not domain, field decomposition of a problem. So what we do is that we solve the antenna independently, and in conjunction of those antenna field, we try to, through automatic workflow, which is a field source coupling or a hybrid solver coupling, we place those near field or far field of an antenna on a platform. Can be anything. It can be your mobile phone if you are doing 5G analysis. If you are doing for aerospace and defense, it can be aircraft, it can be drones. And if for more application, it can be a building or mast where your antenna will be placed. So uh, what will happen is that the field will be linked to those buildings, and for buildings, as your electrical size, or for aircraft your electrical size will be very very high, we can use iSolver or integral equation solver or asymptotic solver depending upon the electrical size. That's how hybridization of solvers happens in CST Studio Suite. I would say like if users is doing this type of a specialized problem, be in touch with our simulation specialist. They will help you out in doing those type of simulation and giving you the workflows for this type of simulation.
Sure. Thank you for the detailed response, Pankaj. We have one more question from Ms. Chanchal. I think she's asking, is there any method that analyze the design in CST with some equivalent circuit, and how we can mix the active and passive component in CST?
Yeah, again, a great question. So if you see, there is a vector fitting method, like if you just wanted to get any equivalent circuit of 3D, but as I said, we have been discussing a lot of time between a schematic and 3D. So of course, you can do all those co-simulation between active element and the passive elements in CST Studio Suite, you have a 3D design, or let's take you have an antenna and amplifier. So a very simple case for design of RX-TX chain. So amplifier, definitely you can have a file of those amplifier in a schematic, and you can have an antenna in 3D. You can do those co-simulation together in CST Studio environment. And this is most established workflow. A lot of customers are using in 5G or for any TX RX design in aerospace and defense for CST Studio Suite.
Okay. Thank you for the response. I hope this answers your question, Chanchal. We have one more question from Durgesh. He's asking, what is the best way for variable sweep in TDR? He's using par sweep now, but is it possible to use optimizer? And if yes, then how?
Yeah, optimizer is definitely can be used. So first, before the optimizer, I would recommend first to use the parameter sweep. You understand with the parameter sweep which variables are mostly affecting your design. Like you can have a 4 candidate of variables which you wanted to even out. Like uh, in a design there can be a 20 variables which can be affecting your design, but you have to choose the 4 main variables which can be affecting the most. So that can you can achieve from a parameter sweep running. Now you have a choosing of 4 candidate. That 4 candidate you can use in optimizer. Then optimizer will give you a best even out. Like if you want a TDR analysis, let's take for a connector design, and in those connectors you can get like I want like S21 to be 0 dB. So those information 0 dB becomes a more harsh requirement. You can give like 0.1 dB or something like that, or 0.001 dB to the optimizer for the 4 different parameter sweep, and you can get that. So optimizer, before optimizer, parameter sweep is a good way as an intermediate step for understanding which variables are more affecting in my design, and then moving on to the optimizer.
Okay. Thank you for the response. We hope that answered the question, Durgesh. Uh, if I'll just check in if there are any more questions. If not, then we will close the session. So in case if there are any more questions, you can raise your hand or you can type them out in the chat box. Okay. I don't see any more questions, but this was a wonderful session, Pankaj. Thank you for your time. And just to inform all the attendees, we will share the recording of this session with everyone so that you can view it at your convenience anytime. And in case if you have any queries related to simulation, you can always reach out to us. So with this, I wish everyone a very good day. Thank you for joining. Thank you for your time.
Yeah. Thank you,
Thank
Mehul,
you.
and thank you, attendees, for having here.
Thank you, everyone.